I'm Yusuf.
I'm Daniel.
And we developed an app that utilizes the phone camera, has it isolate the user's image from the background, and sends the info to another device, which shows the image through the movement of tiles on an augmented reality panel that gives the illusion of a mirror. This idea was inspired by the wooden mirror by Daniel Rosen. So as you can see, the app loads in, and we have this main menu that gives you the option to either act as a client or as a server. Pretty much the person who's sending the image or the person who's receiving it and creating the augmented reality image. I've chosen to be a server for the purpose of this demo. As you can see, it gives you the IP address if you need to manually link the client to the server. It gives you an option of choosing the camera. Then you have the performance option for the resolution, which just operates at a better frame rate, or the maximum supported, which ends up a lot clearer. It gives them a much better image on the mirror. Then you've got the display frames, which is just a visual representation of the isolation on the server, which does not affect the client at all. Then you've got the easy mode or the professional mode, which either locks you into a set camera mode and doesn't allow you to tinker at all, or the professional mode, which gives you all the different options that we have of isolating the image. So once you actually get into the client settings, you are greeted with multiple options. You can either go for the binary threshold, which just isolates different colors, adaptive, which just tries to learn the environment, HSV subdivision, which is my personal favorite, and frame difference, which learns the background as long as the image is still, and then tries to isolate any moving images or any new images that have come in after the background has been learned. But HSV seems to be the most reliable, depending on the background we use, which just is going to show the entire arm almost perfectly. And that is what's going to be sent to the client and presented on the mirror. Side, they are either automatically connected to the server or are greeted with the option to manually input the IP address of the server in case that the automatic connection does not work. So we're going to go ahead and continue with that, which is going to take us to the client settings selection, which is going to give you the status of the connection, and then the option to select the mirror tile size, the mirror material, the mirror tile shape, whether it be square, circle, or triangle, and the anchor type of the actual augmented mirror. Unfortunately, due to the fact that we didn't have two Android phones, we won't be able to showcase an actual augmented reality scenario, only in a virtual augmented reality scenario. After loading in and selecting the anchor point, you can see the image sent from the server on the tiles that are currently moving. If I walk closer to the tiles, you can see that each of them are moving independently and presenting the image that just shown over there, which is this hand. Daniel worked on the mirror app. Daniel then went on to work on the client, and I went on to work on the server. The app starts off with the ARmirror app file, which contains all the global variables and functions that are used throughout the code. This then takes the user to the splash screen, which just loads the app with a fading logo. This leads the user to the server client selection screen, which is a slider that gives the user the option to either act as a client or a server, whether they want to receive the image or send it. After the user selects what they want, they're either sent to the client, which was Daniel's job, or the server, which is what I did. And they're greeted with the server settings activity, which allows them to choose all the settings and options that they want to tweak about the server, such as the resolution of the camera and the type of image isolation algorithm that they want to use. This then starts up the camera activity, which starts the camera with all the desired settings that the user has given them. Depending on whether they chose the easy mode or the professional mode, they will be greeted with either no settings or a multitude of different options for the camera. This is where the algorithms come in. These are many different OpenCV integrated algorithms that isolate the user's image from the background, some more effective than others. I found that the HSV is the most effective depending on the background. I have not yet implemented Otsu.
Let's say that the user decides that they want their device to act as a client. After selecting that option from the initial server client selection activity, this takes them to the client settings activity, which allows the user to specify the client settings, such as the mirror tile type and material type. The client settings activity also implements the UI slider used in the initial server client selection activity. After the user has specified all the proper settings and clicks Finish, the augmented image activity starts, running the mirror anchor and displaying whatever is sent from the server on the client device. The mirror nodes class is responsible for setting the mirror to be renderable and rendering the mirror on command. Tile nodes makes the mirror tiles renderable and renders them on command from top left to bottom right. The rotate function in the tile nodes activity rotates each tile by a certain degree when the server sends a frame to its specific position. This allows the mirror to display any frame that the server sends. The AR core client class or client class receives the client status from the server and presents it to the user through a message, notifying the user that they are connected to the server either as a master client or a slave client, because multiple clients can be connected to the server at the same time.